And as you see on your uh, window, so you have a computer and you're going to say hello world. And if you're going to type something, there will be an HTTP request to the web server. Then after that, you will be able to wait for the response of the server, and the server will try to look on the web server table for the proper response, and in turn, there will be an HTTP response. So we have up to lesson 8. So these are the topics for your whole course. And the bigger topic will be concentrated on lesson 3, although lesson 2 is more on the module part, because I will going to give you a lot of exercise this day. So you need to already have your groupings. And today we cover computer networks. So we will discuss the basic computer systems, network systems, the type of computer network, what are how network communicate. Also, we will have the types of network model, and also the advantages of network model, and also the laboratory modules. Now, for computer network terms, so we have computer network. So network. So what is a network? So it facilitates communication between computing devices, which allows communication between people. So this is a network. And hardware or devices, computer, network servers, and workstations that run operating systems. Specifically, these devices are routers and switches, which move network data from computer to computer and network to network. A software also is a program and other operating information used by the computer. So in this case, software is divided into several parts, but I will not discuss this because you have a separate subject on this. Also, we have operating systems. So it's a system software that manages computer hardware and software resources, and provide common services for computer programs. So OS, so also in information technology, you have another subject for this. And also we have a computer network is a set of computers sharing resources located on or provided by network nodes. So the computers use common communication protocols over digital interconnections to communicate with each other. So this is a computer network. And also we have a common term that we will able to encounter when we open our internet or web browsers. We have cache, or we call this a cache. So it's a high-speed data storage layer which stores a subset of data. It's typically transient in nature, so that future requests for that data are served up faster than the data's primary storage location. So in this case, whatever you able to uh, put information will be stored in a subset of data. And in cases you're going to go back again to the storage location, it's going to be easier for you to access this data because you have already a storage. So that's the purpose of cache. But take note, if you're going to refresh or erase your cache, so the temporary files or the data that being stored will be also erased. And in this case, when you try to access again the web, so it would take time. So that's the purpose of cache. It's to store a subset of data in the web, and it makes the consumer to access the information fast. And also, we have a common term. We have the web cookie or the browser cookie. It's a small data that the server sends to the user web or browser. The browser may store cookie and send it back to the same server and later requests. Typically, a cookie is used to tell if two requests come from the same browser, keeping a user login. For example, it remembers stateful information and for stateless HTTP protocol. How do we see this cookie? For example, if you are going to save your password, so in time it would be easier for you to use the web because you are having already the access. And a cookie also stores information regarding the browser. So if you accept all cookies, so it would also accept all advertisement, all necessary items that the web browser needed to run. So that's a cookie. So you could control also what cookie to be stored or not nowadays. But you must be careful because a cookie can store your information, what things you like and what things you don't like, or what advertisement that you are wanted to look for. So once you try to search something, it would appear on your advertisement. That most of the time you search this certain advertisement and it would appear on your advertisements in your web. So that's why cookie is a trick for other people to buy something, or can make you also influenced by advertisements. Now for virtual networking, so this is a foundation for cloud architecture and applications. It's enable the ability to access, connect, secure, and modify cloud resources. Also, we have common term, virtual private network, or VPN. Is an encrypted connection over the internet from a device to a network. So the encrypted connection helps to ensure sensitive data. Example, we have a credit card and your personal identification. So it prevents unauthorized people from eavesdropping on the traffic and allows the user to conduct work remotely. And we have dark web is a part of internet and made up of hidden sites that you can find through conventional web browsers. Instead, you must rely on browsers and search engine designed specifically to unearth these hidden sites. So example of dark web, we have Tor and other stuff. Okay, so you need to be careful in going to dark web. And now we move to our basic computer system. So what is important in the computer system? So information is important because it's the input to a computer from a device. So such as keyboard. Example on this figure, we have input A. So we type on the keyboard, press A. And in process, the central processing unit processes the information that we the in this side in the CPU, they look for A and try to send it to the output. And now your output letter A will be displayed. Now, in this time, you have this is the basic computer input process output process. So your CPU process the instruction that you type A. So when the computer CPU determines what letter was typed by looking up the keyboard code in the table, and then the CPU sends instruction to the graphics card to display letter A, and which is sent to the computer monitor. So your output is a monitor, your process is your CPU, your input is a keyboard. Also, you have in order for you to see the input, so what you're going to do, you have a word processing tool like Microsoft Word or Notepad. Now for the input components, so we have this basic computer fundamentals. So this is what we call user control devices, and it can be classified to as external interfaces such as a serial, firewire, and USB ports, and it can be used also for input from the external devices. Input is also generated by storage devices such as hard disk that store programs and data files containing computer instructions and data. So example, we have this barcode scanner and other code that can be used as an input. And now we go to the process component. So the computer main processing component is the CPU, which execute instructions from computer programs such as a word processing program and web browsers, and also runs instruction making up the OS. So this provides user interface and environment in which application run. Aside from the CPU, computer usually include ancillary processors associated with input and output devices such as graphic cards. So these processors are often referred to as onboard processor. So graphic cards are included in your so nowadays it's included in the architecture, but we have the classic. This is a von Neumann architecture. So you have input device, and inside you have the CPU, and you have the control unit and the logic unit inside the CPU, and the memory unit that is outside the CPU. And the memory can be random access memory, and also can be read-only memory and your output device. Now we have the output components. So what are the output components? So these are example of your output components, which allows you to visually uh, see, and as well as be able uh, to have a copy of the device. So output components includes monitors and printers, but also it may include storage devices like network cards, speakers, and also external interfaces mentioned previously as input devices. So some of the input devices like universal serial bus allows reading files from the disk and also writing files to the disk. So in both cases, a universal serial bus can be both input and output device. Now we go now to the network types. So we have local area network. So LAN connect computers and peripheral devices in a limited physical area, such as business office, laboratory, college campus, by means of links, wires, Ethernet cable, fiber optics, or wireless fidelity that's transmit data rapidly. So in this case, so this is you have a server and it's connected to the computer, and there are types of LAN. So these are Ethernet, talking ring, token bus, and fiber distributed data interface. So these were discussed in your network one. So you have already background on this. Now we have also the second network type is what we call the metropolitan area, or MAN. It's larger than the local area network, and it connects two or more computers, but resides in the same or different cities. So example, Bacolod City. So you could have a metropolitan area network. At the same time, uh, it covers a large geographical area and may serve as an ISP. So example, you have Smart Bacolod Towers. So those are example of metropolitan area network. And metropolitan area network is designed for customers who need high speed connectivity. So the speeds of this type is around megabit per second, and it's hard to design and maintain metropolitan area network. Now for the last type, we have the wide area network. So we called it uh, it's a network that extends over a large geographical area, although it may be confined in a within the bounds of a state or country. So one could be a connection of LAN connected to another LANs via telephone lines and radio waves, and may be limited to an enterprise or a corporation or organization. So in this case, uh, uh, the technology is high speed and it's relatively expensive. So in this example, we have the cognitive wireless area network architecture in SG communication. So this is smart grid. So you have from home and connected to a tower, and another one connected to another region. Example, we have this Luzon, Visayas, Mindanao. So this tower allows communication between a large geographical area. Now we have to go forward with the internet protocol. So basically, we have to use most of the time open system interconnection reference model. So it defines the typical networking system architecture that is in 7 layers. We have the application, presentation, session, transport, uh, network, data link, and physical. So the computer between different networks or application, the gateway converts information and data and other communication from one protocol or format to another. A router may perform some of the functions of a gateway. An internet gateway can transfer the communication between an enterprise network and internet. So this term, gateway, allows you to communicate to other network. And we have also domain name system. This is what you call the phone book of the internet. So you could access information online through a domain name like NewYorkTimes.com or ESPN.com. So these web browsers interact through Internet Protocol addresses, and it translates domain name into Internet Protocol addresses so that a browser can load Internet resources. Now we have basically this in your networking one. So network king one, we you focus more on cabling. When you say straight through, so it is usually cables primarily used connecting to unlike devices. And example of this is you connect a straight through cable uh, through switch to router. And also, if you want to connect to switch to uh, computer, mostly you use straight through. But on the other hand, you have a crossover. So it's used to connect to two devices without the presence of the router. However, modern broadband router have logic which recognize them, which permits them to work on all devices. So nowadays, so we don't really need to have a crossover, but there's already a logic that allows you to change the make a crossover into straight, which allows them to work on all devices. Whether you have a crossover cable or straight cable, you can work on them. But there are some specific application that we use crossover cable. Now, for your module one, so please, I'll give you time to open your Pocket Tracer. So I give you 5 minutes to open your Pocket Tracer so that we will have to demonstrate this first module. Are you listening?
Yes, sir.
Okay, so please
Yes, sir.
open your Pocket Tracer. Uh-huh. And we will now move to another window. Uh-huh. Where's my tracer? Now, yesterday, so you allow 3 months use of Pocket Tracer so that you will not log in all the time. You will ask you the username password, but you allow them to have a first module is that we will have to uh, connect two computers using crossover cable. Now you try to observe if we use crossover cable. So can you see what I'm clicking? So in Pocket Tracer, there are several types. So in Pocket Tracer, there are several types. So here, what we have is these are network devices. Okay, now I can see now. So this here we are having network devices, and under network devices, if you're going to click, you have these routers, switch, hub, wireless devices, security, and wide area network emulation. On this one, you have end devices. This you have components, and this would allow you to have connection. These are several connections that you will have. So if you click, so you could see the connection type is crossover. This one is fiber and IoT, and this is octal USB connection, coaxial, and this one is serial DCE and serial DTE. So now we will try to demo your. So you get a PC example here, and where's the other one? Okay, here. Okay, so this is and after that you're going to use crossover. So this from your fast Ethernet, and you press this. Now you have your connection. That's for crossover. And you try also to experiment whether you use other other way. So example, you have straight. So what would be the connection there is that you have still the same. So what do you see on the diagram below? You see a red, meaning what do you mean by red? There is no
They
connection.
connected, sir.
They are disconnected. So this one, they are connected. Okay, so that's the difference between uh, the uh, the application of the copper uh, crossover, and you have the straight. How do you make this connection? So since you didn't have a setup yet, so you need to change the IP address, and this would be a different laboratory, I think. This is another laboratory. So you're going to write gateway here, and also change settings. Okay. So the IP configuration also will be made here in order for you to communicate with one gateway. So that's it. But for the meantime, so maybe we'll try this one. And can you see the image on the front? On the Can you see the PC2? Can you see PC2 on the? Okay, so you go to desktop and change the setting. So now we will try to example, if you want to see a simple data sent to another computer, so you need to configure the port first. So this is how we configure the port, but on the next module, there are instructions that you need to follow on how to configure the port. Now for this laboratory, you're just going to observe this one. So this is not really difficult task for your module 1. Okay, so we move to our PowerPoint slide. So this is your module 1. So you're just going to have communication between two computers, and you need to change the IP address of each devices, and just like what we did. So you also have to have the screenshot of the output in the packet tracer after you're done. Next module is to find the MAC address on your computer. So what you're going to do, example, since we already have one MAC address from two computers before, but we haven't yet set up this item. If PC0 and PC1 doesn't have yet an IP address, why? If you're going to hover long on the computer, you'll see that there's no IP address set up. Fast Ethernet not set up. While on PC2, you could see there is a fast Ethernet set up, and as well as this one is already set up. Now, what you're going to do is to go to command prompt and just follow the instruction. So what is on the instruction is to run or type cmd, and you will have to go with ipconfig. Now, if you type ipconfig, what you will see is, do you see the PC2 on the screen? So the IPv4 address is 10.0.0.1, and the physical address, that is your MAC address. And what is the MAC address for this? You have 0000A, and that is F3 B hex 5D44 hex. So that's your PC2 MAC address. Now, after you're done with this, so we move forward to the next. Any questions on module 2? Because we moved to module 3. Okay, no questions. So we move to module 3. Okay, so module 3, after you're done with the MAC address, so you're going to also type ARP. Okay, for ARP, so what you're going to do here, so this one, we did this earlier. So this is what we did for PC2. So PC2 have IP config all, and for ARP, so what's the code for ARP? So for ARP, so this is for IP config, and for ARP, you're going to type ARP in your module 3. So you're going to type ARP as A. So there are no ARP entries found. So what you're going to do, so you make to you're going to check if you have the correct ARP. So suppose you must have a value on your ARP entries for this example. So you need to have a connection between two computers in order for you to have ARP. So if you don't have ARP, meaning why we don't have ARP? Because we don't have connection with the other. So if you put if this would be green, so meaning there will be address resource protocol. But if you are red, there will be no ARP because there is no connection between the two computer. Now for this, if you're going to set up your IP address for your PC0 and or PC1 together, if you establish connection, so you will have ARP in this situation. I don't know if we will, but we cannot simulate because we haven't yet make our IP address. Okay, let's try making this up. So after this, you'll see that you have already have configured your fast Ethernet because you will see 192.168.1.1 when you hover on the computer. At the same time, on this side, you'll see 192.168.1.3, and also you'll see the gateway also. They have the same gateway, and we will try if they will communicate. Okay, so this is just a basic network simulation, not really that difficult. Okay, so simulate, you click this, and you're just going to play. So once you will have a a check. So meaning you will have a connection once you see a check mark. So meaning they are connected. Now, if you try to stop simulation, just click real time. And in case with this, so you'll check your command prompt here, your PC1. So you'll try IP config all. So you have this as your IP configuration and no configuration for Bluetooth and other stuff. What you have, we'll try to check if we have ARP, if it's successful. Now, in this case, you have your ARP. A while ago, as you compared to this one, you don't have ARP because there is no connection between the two. So, where is 192.168.1.1 is that here is PC 0. And if you see on this side, there is no connection because they are on the red, uh, meaning they cannot be connected using a straight through. Only you could access computer to computer by crossover. Okay, so now we close this. So that's actually your lab. So this is your module 3. Is it difficult or not? So it's just easy, okay? So all you need to do is to have packet tracer and try to check if you have uh, if you use also packet tracer in your mobile phone, it's okay. Just put a print screen and you're finished with the laboratory module 1, 2, and 3. Now we move forward to network components. So after you're done with the packet tracer, modules 1, 2, and 3, so we go with the network components. So network interface card is one of the main card used in the motherboard expansion slot. So example of a network interface card, if you have this in packet tracer, trying to check if you could put interface card here. NIC. Need to have NIC. No. Modules. Okay. Okay, so we try to check. Uh-huh. Put a web server here. Example of a network interface card is example we have this card. You put here, but you cannot put directly because you need to have a so this is a 4G network interface card. So if you want to put an interface card on the computer, what is the rule first? What you're going to do first if you want to put a network interface card in the computer? So first, you're going to turn off, and now you're now ready to put interface card on this side. So this would be added. If you put another cards for another purpose, so you could change also, but you need to turn on. to have it configured. So that's some of the network interface cards in Packet Tracer. So what is a network medium? What is network medium, by the way?
Cable that links computers, sir.
Okay, network medium is like a radio wave signal, your cable. So not all network medium class are wired. So you could have wireless network medium. So nowadays, so you could use excuse, I have to check. Okay. Okay, so we go back now. So the third one, we have the interconnecting device. So this device is not really necessary. So this is like a small wireless network configured like Bluetooth. Also, it's a small network wireless device, like you use it on your keyboard, your headphones. Those are small network devices. And okay, let's go back to the okay. Now, so this is a example of a network interface card. So as you see, you have the Ethernet port, the serial port, and another port that can be used for another connections. So this port transform necessary to have a software to interact with the network hardware and software. So this port may have a network OS that allows word processing program to open a document on a server and knows how to request a web page or send an email. So the software also communicates between the OS and the network hardware. So now we have the network software. So the software is divided into several categories. So we have network client and servers. And network client software request this network client. For example, you are the server, so and I am the client, so I will try to connect in your system or in your network. So this allows me to access the resources. Uh, and also, we have the second category of network. We have protocol. When the clients and servers need to send information on the network, they must pass it to the network protocol, which define the rules and format a computer to sending information across the network. So the third one is we have the network interface card driver. So this allows you to format the message correctly and hands the data off to the network interface card driver for transmission onto the network. So steps for your network communications. So we are on the near or finish the lecture. So first step is to as a client, I need to access the resource to another computer, such as a web server or file server. And the user attempt to access network resources by using an application and and send a message to it. And the second is to use a network client software that detects the attempt to access the network. Then the client software formats the message generated by the application and passes the message onto the network protocol. Then the third is the protocol packages the message in a format suitable for the network and sends it to the network interface card driver. Then the last step is that the network interface card driver sends the data in the request to the network interface card and convert it into a usable uh, information that the computer will use. So so this is another scenario when there are two sides of communication session. So this involve a client to trying to access the network resources and a server providing those resources. The steps taken on the server side are essentially the reverse of those on the client side. So the network interface card on the server receives the signal from the network medium and converts them into the message data and which is read by the network interface card driver. So then the network interface card driver passes the message to the network protocol, and the network protocol determines which server software the message is targeting and passes the message to the designated software. So remember, the computer can have many clients and many servers running at the same time. For example, a computer running Windows Server 2012 might be acting as a small as a server, at the same time a file server. Each server function requires different server software. For example, the client here in the GIF. So you're going to send, "Are you there?" And the server message, yes, it responds. And if you want to have an URL, so the server will able to response. Here it is, and there is network communication between the two client and server. So is it important that you must have a server software so that you could receive the message and to respond by sending the requested data to the client computer? So this is how the client access and server to provide resources. Now, on our last few topics, we will discuss on the network models. So we have two types of network models. So we have peer-to-peer and we have a server-based model. In a peer-to-peer network, most computer function as a client or server as circumstances dictate. So when a server acts as server, like a sharing printer is connected and simultaneously act as client by accessing file shared by another computer on the network. So this is what we call also a work group model. So which can take both client and server roles. So in this example, uh, this computer could also become a server and which can also interact to another computer, and this called what you call the peers. So these networks impose no centralized control or security over shared resources. So any user can share resources on his on her computer with any other user computer, and each user can determine what level of access the other users have to his or her shared resources. So you could have a username password. You call this credentials. So if you have a username password as your main entry to this server, so this network can be accessed by group, and you must have the same username password. Now, the second model is we have the server-based network. This is a centralized model, which means that you have a domain-based model, which allows centralized control over a network resources, mainly by providing an environment which the user log on to the computer on the network with a single set of credential maintained by one or more servers. Example of a server-based network, you have your Cisco. If you have your username and password, so you could access the resources from Cisco, and also without a credential, you could not able to download the packet tracer because you need to have permission from the Cisco network to download these. So a domain is a collection of users and computers whose accounts are managed by Windows servers called domain controllers. So domain controllers is primarily uh, controlled, or uh, this is based on Windows server. And users and computers in a domain are the subject to network access and security policies defined by network administrator and enforced by domain controllers. Then the software managing the centralized access is a directory service. Now for your laboratory module 4, this is one of the easiest part, is that I'm going to share my screen, and you're just going to have, okay, so discuss first this. So first, you're going to open your, if you have your computer, so you need to have a group here because not all of you have computer. So what will happen is a member supposed to be having a computer. You will look on your laptop for network and internet, and then you will try to check on the start menu. So you're going to select or type control panel, and you're going to check your Wi-Fi or Ethernet status, and click and view properties and look for the Internet Protocol version 4, and describe the network adapter and observe the activity, the number of bytes sent and received, and the network connection details. So you will have a screenshot of the output. So in this case, so you have this example. Okay, so press window icon. You press the window icon, and you need to type control panel. You type control panel. You will see network and internet. So this, so you could click view. So click this, and you could view the network status and task. So in this type, I'm using Wi-Fi. So I'm going to click Wi-Fi, and you try to have describe this the properties. So you go to properties. Since we are on studying IP version 4, so you're going to have to go to IP version 4. And since we are not, I'm not enabling my manual IP address, so I'll just have automatic DHCP. So that's it. So that's your laboratory module 4. So any questions with your laboratory module 4? So any questions on your laboratory module 4? So you now have 4 modules, 3 modules added to your work for this week. So now, so this is by group. What will happen is, so you need to group yourselves, and you'll have the same group number but different last name and first name when you try to submit. As discussed yesterday, you have the format on how to submit your work. Okay? And after this, I'm going to give you the template of the document that you need to fill in when you're going to submit your work. So we have the terminologies in so we have ICMP. So normally we use ICMP, Internet Control Messaging Protocol. You use a ping to connect to another computer. Example, if you're going to ping our crossover connection before, okay, we try this. Share, share, okay. So this, there are option. So this is 192.168.1.3. So we're going to ping our connection to this IP address. So what is the IP address of this? So this is 192.168.1.1. So in order for us to ping, so we need to type ping, Control V. Let's try. That's ICMP. So now we have connected as a result. So you have how many packets sent? You have 4, received 4. You have 0% loss, and the round trip is about a millisecond maximum. Now we will have this scenario. So if you want to connect to this, so what will happen? What you will see as expected for this? So this you have IP address of 10.1.1. Okay, so we need to ping on the other computer. PC2, ping. Oh, what do you expect for this simulation? Of course, no connection will appear because you have no connection with PC3 at the same time with PC2. And what you will see is that there will be, I think, 100% loss for this example. Yes, there will be 100% loss because no connection is being implemented here in PC2 and PC3. And this one you have PC0 and PC1 are already connected. Okay, so uh, okay, now we go to finish our lecture 2 by PowerPoint. And earlier, we have IP address. Normally, it is a 32-bit address. So 32-bit address is assigned in every network. So how we're going to measure 32-bit address. So in our next topic, so divided by 4. So that's why we have 192.168.1.2. So the maximum value they could have in each point is 8. So 8 times 4, that would be 32. So in each 192, what is the maximum value if you have 8 bits? Anybody? What is the maximum value? So earlier, I typed the IP address, right? So
64.
no. As you see, I type here the IP address. The subnet mask is your maximum value. This one. You cannot see it, right? So I will share the screen. So this subnet mask. So if your value is 255, so this is on each point you have your value. So the maximum value is from 0 to 255. How? Because you raise it to the 7. And 2 raised to 7 is 256. And what happens to the 2? That would be your network address and your network number. That's your host ID and your network ID. So later part, we will discuss each. And these would be your basic things that you need to learn. The maximum value you could have is 255 here. And that's it. That's why we have these values. So Ethernet is one of the common LAN standards for hardware and communication and cabling. And the speed is about 100 megabit per second Ethernet port. So you could configure it in Packet Tracer. And the OSI model, we consider usually 7-layer. We have the PDU, the Protocol Data Unit. So that is the data that we're going to transfer. And the simulation earlier, we demonstrated that you could transfer data from one computer to another by implementing this. So this is a sample PDU. So you send data here to here, and you simulate. So you have two data to be transferred. And in cases he receive, it responds. And once they receive, it check from PC 1 and receive from PC 2, and you receive the second one. So that's the end of simulation. And also you could extend this if you want a long simulation. So you have okay. Okay, we start. So this is just a basic simulation computer to computer using crossover cabling, unlike devices. So you see your PC0 send as well as receive one data, while PC2 receive two. So that's how PDU works on Packet Tracer. Now we go where are packets found. So at layer 3, so they are represented by envelopes as we noticed, and also device table. Earlier we performed ARP already. You could perform ARP if you are connected to the computer. If you are not connected, meaning you could not use ARP because you are going to store the pair of IP address and the MAC address. So the last part, scenario, is the one topology with a set of PDU placed in a network to be sent at specific time. Using different scenarios, experiment with different combination of packets using the base topology. So next meeting, we will have this example. I will just stop my module here, and next week, this would be your module 5, so that you will have your first network. Is it okay we stop at module 4 first? Maybe it's too much. This is going to take time. Maybe we have this next week. Okay? As a summary, so we have discussed the network components of computer, considered input, process, output, and also we also discussed the external interfaces. The universal serial bus can be both input and output device. And we discuss also the types of computer network. We have local area network, metropolitan area network, and wide area network. Most network communication starts by a user needing to access a resource on another computer, such as web server or file server. Just like when you going to log into mail, log into Google Classroom, so you need access. So if I'm not allowing you to access the Google Sheet, you could not write your name or you could not enter the class. So that's how network communication works. So you need to inform me that you're going to access, and I will give you the access. And also, network interface card is an add-on card that is plugged on the motherboard expansion slot and provides communication between the computer and the network. And the OSI, a reference model, are the primary architectural model for communications between computer systems. So how many layers do we have? In your networking one, you have discussed this already. So you have how many layers? You have 7 layers. Okay. As a summary, it's important to discuss the advantages and disadvantages of the following network model. So we have peer-to-peer network and the server-based network. So for resource access, so in peer-to-peer network, it is distributed among many desktop client computers, while on server-based network is centralized. And on security, user control their own shared resources. So there are issue with security. And for centralized, security is managed centrally. So users have a single set of credential for all shared resources. It is this best secured environment is necessary in server-based network. Performance, so we have desktop OS is not turned on for resource sharing, so they are access to shared resources are can be hindered by users running application. So once other user use this application, there are chances that you could not be able to use it because there are too many using it already. And server OS is tuned for resource sharing, and the servers are usually dedicated to providing network services. So meaning, since you are centralized, you can benefit, all of you who are connected to centralized network, you could benefit all the resources for cost. So there is no dedicated hardware or server OS required, but the lost productivity caused by increasing complexity can raise costs in the long run. That's for peer-to-peer network. Normally, peer-to-peer network, if you want to communicate with Bluetooth to another person, so you have only uh, either two of you going to communicate. So you just a temporary access is required. So nonetheless, it's not really costly. But for server base, it's higher upfront cost because you have dedicated hardware and server OS and additional ongoing costs for administrative support. So this is how mostly we use server-based network to have security at the same time to prolong our uh, to provide shared resources evenly to the client. So this is the end of our lecture, and thank you for attending the class. Hopefully you could meet up with other section, but I don't want them to uh, I'll just continue giving the deadline, but I don't know if they could manage to catch up the time because it's already second day. So any more questions regarding the modules that you will have after this class?
Sir, ask ko
Yes.
tani, sir, CMD vlog, sir. Paano to sa sir?
Ang
Ang
sa
CMD,
ang,
Windows lang, sir, or sa
ang module 3 amo na ang module 2 and 3 you use packet tracer. Sa packet tracer, there's a item in packet tracer that you could use. I'll stop presenting and I check this packet tracer. This one. Okay. Sure. This is not good. Okay. Example this. This one. Since we connected the PC1, so if you double click PC1 and there will be a okay, I'll share this. Okay, stop sharing. Okay, kaya hindi makita sa sa screen. So okay, window. Okay, this one shared. So after you click PC1, right? So if you connected that to computer already, so you go to desktop. But since we want we'll start new one. So you go to command prompt. This you click this, and you have to set up your IP address. You click this. Uh, this one, this we're going to use the IP configuration, and you don't need to use your own command prompt in your computer. Okay, is the answer once you're
uh,
finished? Yes. Okay.
okay na, sir. Thank you, good, sir.
Any more question?
Sir, ako sir,
Yes.
ang sa ano bala sir, sa ano sa Cisco Packet Tracer na bala sir.
Yeah.
Hindi may duwa to ka PC bali ang apat tanan. Ano to ang sa dalom sir nga duwa nga wala ang may red lang nga linya.
That is a straight through.
Straight through to sir.
Oh, ang
Ang sa babaw ya sir.
ang may dash amo na sa ang crossover.
Okay.
So meaning you cannot connect computer using straight through.
Straight through.
So sa networking one nyo, amo na sa ang theory. You could only connect PC to PC using crossover.
Kung straight through, sir, hindi sa pwede.
Hindi sa ano.
Okay, okay.
Okay? So, uh, any more questions? Ipakita ko lang niwa.
Sir, nang sa
Yes?
may IP address bala sir how nang tawag po sa ganit sir pao ng IP address sa buhay mask kag default gateway. Kay kagidabi sir wala binag-appear sang pag-discuss mo ba sir?
Ang subnet mask and default gateway.
Oo sir.
Usually, ang akon gina-input is ano lang, ang imo na IP address. But yung gateway, you need to have example again. Share screen. So again, you click the computer. Example, yung click mo ang PC1. So to set up your IP address, you could type, you could click PC1. Excuse. After you click PC1, you go to this one, window. Okay, so click PC1. You click this. You click mo na yung PC1. Once you click it, so there will be a new pop-up. So ang pop-up is this one, a new window. So this would be the window. Once you click PC1, then after that, you could use this one. You could use this as your default gateway as an example only. And also you could use this tab. We will not use programming tab. We will only use most of the time desktop and config tab. So you set up your IP address on this side because once you type here, on the latter part, we will discuss why. So example, this one. So once you type this, automatically, this is class C. In your networking one, diba? You finish already networking one. So as you type here, automatically you will have the conversion of the subnet mask. So when you type gateway, so the gateway between two computer must be the same so that you could communicate with both. The only thing is the difference is you have the different IP address because the other computer is dot 3 and you are dot 2. So for your gateway, so you have the same gateway in both computer, PC0 and PC1, but you will have different IP address. Because if you have the same IP address, there will be an error. Like if I type here 3, it's already taken. Ma-reply na siya na it's taken from the previous.
Sir.
So in this scenario, you follow only you could have also class. What class is this in your networking one? What type of IP address is this? Because if you enter this, you will have. If you enter this, what will be the IP address in your networking one? So this is your 255. As you see earlier in your PC2, sa PC2. Okay, I'll share the screen. This is another example. Sharing. So I click now PC2. So what you have here is this IP address. So this is also different IP address. So this is class. What class is this? You have class A, class B, and class C only used for networking, right? In your networking one. Do you have background in this is already advanced networking, so I expect you learn a lot in networking one. So this is class A and class A IP address. There's also class C. So there are three types of IP address. So once you type 10.0.0.0.1, automatically the IP, the subnet mask is being written, so you don't need to write subnet mask. All you need is to have to write your IP address and your default gateway. That's it. Did I answer your question?
Yes, sir. Thank you. Good.
Yes. Okay. Thank you.
Sir, paano mamalaan kung connected na sila, sir?
Once you have a green connection like before we have this, and you will simulate it. So this is PDU. Example, we send data here, and you try to simulate and play. Once you have transferred data, so meaning you already transferred it correctly. Now, what do you think is the error here? Why is it nag X? So yeah, once you see an X, meaning there's no transfer. You see failed because we change our IP address because we don't have an IP address. So that's it. Oh,
Okay, sir.
and
Thanks.
nine
Good.
to that two tama ba? Or that three to na. I think this would be okay. Hopefully, we'll try. Kung okay na. Once you see a check mark, okay, so the check mark is good. There's successful. On the bottom, you will see successful transfer. That means that you transfer the PDU successfully. So that's it. Okay. Any more question regarding packet tracer? So if there are no questions, we're going to end recording and